Here we're asked to graph the following and then identify the domain and range. So this one's our parent function, which we've probably gone through before. But the idea here is that we can always plot some x and y values. I'm going to plug in some negative ones as well as some positive ones. And basically I would say like, hey, what is g of -3? I'd plug in -3 for x. I know the absolute value makes it positive, and so then we know my y value is 3. And so I could continue doing that with as many points as I wanted to graph. In this case here, I'm going to do these 7. So if I plugged in -2, I would end up getting +2. If I plugged in -1, I'd get 1. If I plug in 0, I'd get 0. If I plugged in +1, now just again, making sure we understand that it doesn't flip the sign, but it just makes the number inside positive because it is the distance that it is from 0. So 1 still has a distance of 1 from 0. And so all of these last 3 here are just the positive versions as well. So when we plot those points, we should see on the graph here that it makes this V shape, which absolute value makes sense here. Let's see if I can make it a beautiful line here. Nice. And another one, again, this is not perfect, but you get the general idea. Oh boy. And so this here should show you our absolute value function is like a giant V, and it goes on forever in both directions there. So when we talk about the domain, we could say in inequality notation, negative infinity is less than x, which is less than infinity. The range, however, does not go to negative infinity because the lowest value here is at 0. And since it hits, actually, let's do it in interval notation. Since it hits 0, I have to use that hard bracket here, 0 comma infinity, because it goes up forever, but never touches infinity. So we use a parenthesis for the range.